Okay, hello. Welcome to the next video. If you are watching this in 2020, then this is right before a long weekend, so I hope you enjoy it. Just FYI, I do plan on using these videos in the future, so it may not be 2020 when you watch this. Um, we are going to be talking about separation techniques today. Um, First of all, this video is going to be a little bit shorter than the others, but also we're going to be putting together a number of different concepts from the last couple of days together in this lesson. So we've spent some time talking about different classifications of matter, states of matter, and then physical and chemical properties and changes. Today, like I mentioned, we're going to be putting a lot of these concepts together as we look at separation techniques. Okay? So, separation techniques or processes are processes that exploit physical or chemical properties of substances to achieve separation or purification of those substances. Okay. My background, I have a bachelor's degree in chemical engineering. This is maybe something that you might not learn in another chemistry classroom, but I had an entire class in college called separation processes. So I know a lot about this. It's really interesting, and it's definitely relevant given some of the content that we have experienced recently. So, elements and compounds are rarely found in purified states in nature. Okay, usually, if you want a pure element or a pure compound, right? Those are the two pure substances, right? Elements and compounds. If you want them purified, you're not going to find that in nature. You have to do something to a certain material to like extract those pure substances from how they're found in nature, which is usually in the form of some sort of mixture. Okay, so separation techniques are vital for our modern industrial economy. A lot of industries rely on having raw materials that are in purified states. Okay, elements and compounds. So here are some examples. Aluminum. You can extract aluminum from bauxite ore using the electrolysis process. Distillation of crude oil. So crude oil that we drill up from the bottom of like the Gulf of Mexico, like underneath the Gulf of Mexico. Crude oil can be distilled to produce a wide variety of things like natural gas, kerosene, gasoline, plastics, not plastic itself, but the precursors that are used to make plastics. You can distill alcohol from fermented grains. We do a lot of that here in Kentucky, the home of bourbon, of course. And another example, something that I've personally worked on in my short career as a chemical engineer prior to teaching, stripping of carbon dioxide from power plant exhaust to reduce greenhouse gas emissions. Okay, so these are just some examples of ways that you can separate or really purify things from mixtures. Okay, so properties are key. Okay, in order to achieve separations of mixtures into pure substances, differences in the properties of those substances are exploited or taken advantage of. Okay, so it's the fact that the different pure substances that make up a mixture, the fact that those different substances have different properties, that is what is used to separate them from one another. Okay, both physical and chemical properties can be taken advantage of in separation techniques. Okay, and these are just a few examples. This is not an inclusive list. Okay, so there are other examples than this, but some examples of physical properties would be melting and boiling points, density, magnetism, and then chemical properties are a little bit more vague, generally just reactivity or lack of reactivity with certain things, and then like attraction or a lack of attraction to other chemicals may be used to help separate things. Okay, so we are going to talk about distillation in detail. This is the only separation process that we're going to talk about in detail. Your all's assignment is actually going to be to investigate some other separation processes. Okay, so nobody's going to get to do distillation because we're talking about that one sort of as a group. But the other separation processes, which I will talk about later, you're going to be investigating those on your own. Okay. So how does distillation work? What is distillation? Okay, so the process of distillation separates liquid mixtures by exploiting the fact that the different substances in the mixture have different boiling points. Okay, so remember, boiling point is a physical property. So here, I'll read this first and then I'll go to the diagram. It says, as the mixture heats up, the substance with the lowest boiling point will start to boil first. The gaseous vapors of that substance are channeled to another chamber where they are cooled and condensated back into a liquid. So this right here is an example of a distillation setup that you might have in a lab or even in a classroom. What's going on here is the mixture is inside of this flask right here. So like number 15 represents the initial mixture to be separated. Okay, you heat it up. That's essentially what's going on here. Okay, you heat it up to the point where something in the mixture starts to boil. Okay, let's say this is only made of two different substances, right? This mixture. The substance with the lowest boiling point is going to start to boil first, right? That makes sense. If you have two substances, say one that boils at 75 degrees and another that boils at 150 degrees, as soon as you get to 75 degrees, that first substance is going to start to boil, okay? So it's going to start to boil. Its gaseous vapors are going to travel up the still, and they're going to be channeled into this area, okay? Now this blue stuff here, this is actually connected to sort of another machine, and this is really, you can make simpler distillation setups than this. This is kind of a little bit of a fancy one. But what goes on here, this blueness here, the 6 and 7, these represent like cool water that is on the outside of this tube. That cool water will cool the gaseous vapors down and cause the gas to condensate back into a liquid. And then it falls in this direction towards this secondary chamber, okay, where it can be collected. Okay, so number 8 here represents like the pure substance that boiled first, right? And if this substance never gets to 150 degrees, right, the boiling point of the second liquid, then technically speaking, right, and this doesn't actually happen in reality perfectly, but it's pretty close. Technically speaking, you're going to end up with all of one liquid over here and then all of another over here, right? The one that boiled first, the one with a boiling point of 75 degrees is going to end up over here, and the one that had a boiling point of 150 degrees, it's going to stay over here, right? Because, I mean, ideally you would never get the temperature all the way up there, right? You're trying to separate them, right? So the only reason that the separation technique here works is because those two different liquids have different boiling points. Okay, if you were to try to do this with two liquids that have the exact same boiling point, that's not going to work, right? Because they're both going to start to boil at the same time, and then you end up with both of them over here and both of them over here, and you haven't separated anything. Okay. So distillation can actually get super complicated. You may have seen some structures like this out in Kentucky. This is also really common sight down along the Gulf of Mexico, and that is because of crude oil. Okay, distillation can be used to extract many different substances from a single mixture using these really tall distillation columns. Okay, and you can actually chain these together to achieve separation of like hundreds of different chemicals from a single original mixture. And that's what happens with crude oil. Crude oil has tons of stuff in it, okay? And so there are chains and chains and chains of these distillation columns that help separate all the different chemicals into pure streams, okay? And the details of this are super complicated, right? It's definitely not as simple as this picture here, but that's why people go to school to be chemical engineers, right? To learn about distillation. People out in the real world could be distillation experts, and that's like all they do, right? They're a chemical engineer and they know all about distillation of crude oil, for example. Okay, sorry about the bright screen. This picture only really looks good if it's against a white background. So this one right here is just an example of one of those distillation columns that you might find at a crude oil refinery. Just to walk you through the process one more time, here's what happens, right? You send the initial mixture into like a furnace, right, to heat up. and that comes in the middle of the column. And the way that these things work is essentially the same as that first picture, right? The things that boil easiest, right, the things that have the lowest boiling points are going to rise up the column easily, okay? And so, for example, gases bottled in natural gas that have the lowest boiling point, those are going to rise up the column and zip on out of there, okay? And those can be separated from the rest of it pretty easily. Things tend to sort of striate in layers, okay? And so things that are the heaviest or that have the highest boiling point, they don't boil very well when they're heated, right? They remain a liquid or barely start to boil, and so they fall towards the bottom of the column, all right? Now, let's take this one right here, right? The 390 degrees Fahrenheit, the kerosenes. There may be multiple different chemicals here, right? So let's say this is about 390 degrees Fahrenheit, but there's a bit of a difference here, right? We have a stage at 300 and then a stage at 570. So everything that's sort of in between there or around 390 degrees Fahrenheit, this may go to a second distillation column that then further separates out all of these materials, okay? And this is what I was talking about in terms of like the chaining of all these different columns together. All I really need you guys to know, though, is like I'm not going to be asking you about all these nitty-gritty details. I just wanted to give you a real-life example. All I need you to know is that distillation uses the fact that different liquids have different boiling points to be able to separate them, okay? All right, so let's talk a little bit about what your assignment is going to be today. I'm talking about this right now instead of in class because I want to maximize the amount of time that we have in class for you to work on this assignment. So here's how it's going to go. Groups of 3 are going to be decided randomly during class. Okay, we're going to use breakout rooms in the Zoom meeting to assign those different groups. I'm going to try to avoid having groups of 2, so that might mean that we end up with 1 or 2 groups of 4. And in that case, I'll be sure to let you know if that applies to you. But they will be decided randomly, okay? Each group is going to be assigned a specific separation technique. I have a list of them, which I'll share with you in class next time. Each group is going to create a Google Slides presentation about their assigned separation technique. And I've got a rubric that I sort of get into here and that I'll show you on the next page that tell you everything that needs to go into the presentation. I'll read them here. Firstly, you need to identify the physical and or chemical property that is exploited in that separation technique. Second, you need to explain how those properties are exploited to achieve separations of mixtures. Basically, what this means is you need to tell me how does that separation process work, okay? Third, describe a real-world application of the technique. So for example, if you had distillation, then you would talk about the way that crude oil is distilled to produce different substances. Okay, and then we get to, you need to include a model, okay, of the real-world application appropriately labeled. I want you all to draw this model. It does not have to be fancy. Obviously, you're doing it online, so it's going to need to be done with either inside of Google Slides or with some sort of like drawing program. I can give you some resources there if you need it. And then lastly here, your information needs to be organized well. Okay, so use bulleted lists, tables, diagrams, etc. as appropriate. And then finally, cite any sources that you use in APA format. This is the rubric that I'm going to be using when I grade your all's presentations. We're not actually going to be presenting them per se, but you are going to be making a Google Slides presentation. As I grade each one, I'm going to be looking for those 5 big things. Okay, and you're going to get a score, 5, 3, or 1. I may assign some 4s and 2s if I feel like you're in between on these categories. We'll go through the full details of this rubric in class, but it's here in case you want to take a look at it ahead of time. Okay, and as always, the links are available to the slides in Canvas. Okay, so that's it. We'll dive into the assignment next time. Hope you enjoyed the video. Thanks.